Welcome to G Fun Facts Online. Today we're tackling a topic that affects millions of lives with terrifying immediacy: anaphylaxis. For many, a single peanut, a sip of milk, or a piece of shrimp can trigger a life-threatening allergic reaction within minutes. Living with a deadly food allergy is a constant tightrope walk, where a simple meal can become a fatal mistake. For years, this has been a growing public health crisis, but a crucial part of the puzzle was missing. Why do some people with a food allergy only get mild symptoms, while others face a deadly threat from the smallest exposure? Today, we're exploring the groundbreaking science that is finally answering that question and uncovering a potential way to disarm this silent threat. Let's start with the sheer scale of this issue. Food allergies have exploded over the past few decades. In the United States alone, 33 million people, including nearly 1 in every 13 children, have a food allergy. That's an increase of 50% since the 1990s. Peanut allergies in kids, one of the most dangerous, more than tripled between 1997 and 2008. And this isn't just happening in America. The UK has seen a 5-fold increase in that same period. Today, the 9 most common food allergens, often called the Big 9, are milk, eggs, peanuts, tree nuts, like almonds and walnuts, fish, shellfish, wheat, soy, and the newest addition, sesame. What's truly alarming is that the severity of these reactions is also getting worse. Over 40% of children with food allergies have experienced a severe reaction, leading to about 200,000 emergency room visits each year in the US alone. Scientists have floated theories like the hygiene hypothesis, suggesting our ultra-clean environments have left our immune systems improperly trained, but the exact cause remains a mystery. The reality is a generation living with the constant risk of anaphylaxis. So what exactly happens inside the body during an anaphylactic reaction? For over a century, we've had a classic model for this. It all starts with a mistake called sensitization. Your immune system misidentifies a harmless food protein as a dangerous invader. In response, it creates a specific type of antibody called immunoglobulin E, or IgE. These IgE antibodies then act like tiny tripwires, attaching themselves to the surface of immune cells called mast cells and basophils, which are scattered throughout your body, especially in your skin, lungs, and gut. These cells are now primed and waiting. The next time you eat that food, the allergen binds to these IgE tripwires, causing them to activate the mast cells. This activation is like flipping a switch, causing the mast cells to release a flood of powerful chemicals. The most famous of these is histamine, which causes blood vessels to leak, leading to swelling, a drop in blood pressure, and constricted airways. Other chemicals, like leukotrienes and platelet-activating factor, join the assault, amplifying these effects. This chemical storm produces the terrifying symptoms of anaphylaxis all over the body: hives and swelling on the skin, wheezing and a closing throat in the respiratory system, a weak pulse and fainting from a cardiovascular crash, and nausea and vomiting from the gut. Without immediate treatment, this cascade can be fatal. The body's own defense system, in a case of mistaken identity, unleashes a war on itself. But this classic IgE and mast cell story had a huge hole in it. It couldn't explain the dramatic variability in reactions. Why could 2 people have similar levels of IgE antibodies to peanuts, yet one might only get an itchy mouth from an accidental exposure, while the other ends up in the emergency room fighting for their life? That question has puzzled scientists for decades. But now, thanks to 2 independent studies in mice published in August 2025, we have a revolutionary new piece of the puzzle. The answer, it turns out, might not be in the blood, but in the gut. Researchers discovered a specific immune pathway driven by inflammatory molecules called leukotrienes, and this pathway seems to be the key difference between a mild reaction and a deadly one. The investigation zeroed in on a gene called DPEP1. This gene produces an enzyme in the small intestine whose only job is to break down leukotrienes. The scientists found that mice who were resistant to food-induced anaphylaxis had a highly active version of this enzyme. It efficiently cleaned up the leukotrienes in their gut. In contrast, the mice who were highly susceptible to anaphylaxis had a much less active version of this enzyme. This meant that after eating an allergen, leukotrienes built up in their intestines. And here's the critical discovery. This excess of leukotrienes makes the lining of the gut more permeable or leaky. It essentially opens the floodgates, allowing far more of the food allergen to pass from the intestine into the bloodstream. Once in the blood, the allergen can circulate throughout the body and trigger that massive systemic chemical release from mast cells that we call anaphylaxis. It's not just about whether the allergen is present, it's about how much of it gets absorbed into your system, a process directly controlled by this leukotriene pathway in the gut. A parallel study at Yale confirmed this is specific to ingested food allergens, not injected ones, highlighting that there's a unique mechanism at play when we eat our allergens. This discovery is more than just a scientific curiosity. It immediately pointed towards a potential treatment using a drug that already exists. Since leukotrienes are also major players in asthma, scientists turned to an FDA-approved asthma medication called Zileuton, which works by blocking the body's production of leukotrienes. They pre-treated highly susceptible peanut-allergic mice with Zileuton before giving them peanut extract. The results were, in the words of one senior author, actually shocking. An incredible 95% of the mice that received the drug showed almost no symptoms of anaphylaxis. The drug flipped their risk from 95% susceptible to 95% protected. This suggests a completely new strategy for managing food allergies. Imagine being able to take a simple pill before going to a restaurant or a party, a situation where cross-contamination is a risk. This pill could temporarily block the anaphylactic pathway, providing a safety net and preventing a severe reaction from ever starting. Of course, human trials are still needed, but a proof-of-concept trial is already underway. Because Zileuton is already FDA approved, the path to using it for food allergies could be much faster. For the first time, a preventative oral medication for food-induced anaphylaxis seems genuinely within reach. While we wait for this exciting potential therapy, it's crucial to understand the tools we have right now. And the absolute #1 non-negotiable treatment for an active anaphylactic reaction is epinephrine. Administered through an auto-injector like an EpiPen, or more recently with a new FDA-approved nasal spray called Neffy, epinephrine is a rescue drug. It works within minutes to counteract the deadliest symptoms. It constricts blood vessels to raise blood pressure, relaxes airway muscles to make breathing easier, and reduces swelling. Anyone at risk for anaphylaxis must carry 2 epinephrine devices at all times and seek emergency medical care after using one, as a second wave of symptoms can sometimes occur hours later. Beyond this essential first responder, a new era of proactive treatment is dawning. Oral immunotherapy, or OIT, where patients consume gradually increasing amounts of their allergen under strict medical supervision, can desensitize the immune system. In February 2024, the FDA also approved a drug called Xolair for food allergies. It's a biologic injection that works by targeting and inhibiting the IgE antibodies themselves, preventing them from ever arming the mast cells. This doesn't cure the allergy, but it significantly reduces the severity of reactions to accidental exposure, offering a powerful shield for those with multiple severe allergies. Until a definitive cure is found, living with the threat of anaphylaxis is a matter of constant vigilance and preparedness. Everyone with a severe allergy needs a written allergy and anaphylaxis emergency plan from their doctor, shared with schools, workplaces, and caregivers. And since a shocking 25% of allergic reactions at school happen to kids with no prior diagnosis, community-wide preparedness is vital. This means training school staff and stocking undesignated epinephrine auto-injectors that can be used on any child in an emergency. Clear food labeling and public policy are the final pieces of this safety net. The journey to understand anaphylaxis has been long, and for generations, The only advice was strict avoidance. But the science is accelerating. The discovery of the leukotriene pathway is a true paradigm shift. We are moving from a world of fear and avoidance to one of proactive protection. The puzzle of anaphylaxis is finally coming together, and with it comes tangible, powerful hope for millions living in its shadow. Thanks for listening to Fun Facts Online.